Okay, hi guys, we'll be continuing on seeing some more on Victor Mead's method, and then we'll be seeing some of the questions on the same. Okay, so let's get started. So in the previous lecture, we saw that P of wet air is equals to pressure of dry air plus pressure of H2O G. Okay, and pressure of dry air can then be written as pressure of wet air minus pressure of H2O G. Okay, so we can also write that P air and volume of air is equals to number of moles of air and multiplied with R and T, and we can write that number of moles of air is equals to means we can actually, in several of the questions you will be given the moles of air, using which you can actually have this relationship, and you can write the same for H2O particles as well. Okay, so I'm not writing that again. Instead, let's move on to see a question. So let's suppose in Victor Mead's apparatus 0.2 gram of volatile compound 0.2 gram of volatile compound displaced 63.3 ml of air over water at 20 degrees Celsius and 740 mm of mercury. So you have to calculate molar mass of compound. So here we can solve this question by using that pressure of dry air would be equal to pressure of wet air minus pressure of H2O G. Okay, so pressure of wet air can be, so here I missed one liner, that you have been given that the vapor pressure of H2L at 20 degrees Celsius is vapor pressure. So by the way, this P of H2OG can also be written as vapor pressure of H2O L. Okay, so vapor pressure of H2O L at 20 degrees Celsius is 18 mm of mercury. So putting these values in the pressure terms, so pressure of wet air is given 740 mm of Hg, and pressure of vapor pressure of H2OL is given as, it can also be written as pressure of H2OG is 18, so resultant would be 722 mm of Hg is the pressure of dry air. Okay, so what is the amount of air displaced? Amount of air displaced is this. So obviously 760 mm is considered 180 m. Okay, so pressure would be 722 upon 760 mm. Okay, as unitary method application we can apply to get 1 mm of Hg is equal to 1 upon 760 atm, and similarly 722 mm would be equal to 720 upon 760 mm. Hence we get that the pressure is 722 upon 760, volume displaced is 63.3 upon 1000 in liter. Okay, and as we can see that this is the volume displaced, and this volume displaced would then be actually covered up by moles of H2O, or rather the moles of volatile substance. So if you can just see here that, let's suppose in a vessel there were particles of air, okay, initially, and then it has particles of air plus we have a nitrogen gas also. Okay, so number of moles of N2 which actually gets into the vessel would just be equal to the number of moles of air particles which have been, or air moles which have been displaced. Okay, so now if I am saying that 63.3 ml of air was displaced, okay, so this air would be displaced, or the moles of air would be displaced by the gas, the compounds, gaseous moles which were introduced into the vessel. Okay, so in this case an air displaced would be equal to number of moles of compound added. Okay, so we would be getting that number of moles of air, so an air which was required here would be equal to number of moles of compounds which were added. And how many moles of compounds would be added? That would be 0.2 upon molar mass of solute into, obviously you have 0.082, and temperature you have been given 293 Kelvin. So from here molar mass of solute can be calculated, which should come out to be 80 gram per mole. Okay, so this is the answer. Okay, now let's see another method, which is silver salt method. So it is used to find molar mass of organic acids. Organic acids. Okay, so this contains C double bond OH group. Okay, so we'll see the example and you'll understand. Suppose we have RC double bond OH in aqueous phase reacting with AgNO3 again in aqueous phase to form RCOAg aqueous, which is salt, plus HNO3 aqueous. Okay, and step 2, this is step 1, and step 2 would be we have RCOAg aqueous, which on heating gives Ag. So we'll just apply POAC for Ag atoms. Okay, so that would be X upon mass of RCOAg would be equal to Y upon mass of Ag. Okay, so molar mass of RCOH is actually molar mass of RCOAg minus molar mass of Ag plus molar mass of H. Okay, so here we are assuming that we have X grams of this compound and Y grams of this compound. Okay, so for calculating molar mass of RCOH, you have molar mass of RCOAg minus molar mass of Ag plus molar mass of H. Okay, so why do we need to calculate this to have the molar mass of RCOH? Because R is unknown. Okay, hence you have to use the molar mass of RCOAg. Okay, so once you get the molar mass of RCOAg, if you know X and Y and molar mass of Ag, okay, so using that you can know the molar mass of RCOH. Okay, we'll be continuing on seeing more examples of the silver salt method, which is used to find the molar mass of organic acids like this one, in the next lecture. Till then, good luck and goodbye.